One of the ways I can make the particles look a little better in the OGL view is to add a little bit of alpha to the color of the particles. Again, if I just press play, just truck in a little bit, there's absolutely no alpha on the particles themselves. If I double click on the Turbulize color by gradient, I can click on each position and turn down the alpha color from totally opaque to partially transparent. So I'm just taking the alpha from a value of 1 to about 20%. And again, this value will be changed quite a lot as we go into the into the render tree and start to work with our volumetric shaders. But again, just for now, to make the effect just look a little more appealing as we move through the timeline. My next task is going to be to get rid of the particles that fall below the grid. And if we look at our grid, the position of the grid is a value of 0.73. So what I can do is I can run a little bit of a test that tests the particle position. And if the particle position goes below a value of 0.73, or we can specify a slightly lower value so that the particles that half penetrate the grid don't disappear immediately, we'll simply just delete them. So to do this, I'm going to have to run some kind of a condition. I want to test whether or not the particle position is less than 0.7 on the y-axis. So I need to get the particle position from my graph. To get the particle position is very easy. If we clear off our filter node, we can look under particle getters. Just as we can set particle information, we can get particle information. And I'm going to get the particle position. So if we actually look up particle position, we have a getter here. Particle position is a 3D vector. We're getting an x, y, z position. But I actually need to pull the y-axis from the vector and evaluate that without evaluating x and z. So I need to convert this 3D vector to 3 separate scalar values. So if I look under the conversion nodes found under the Tools category, and I scroll down, we'll find that we have a 3D vector to scalar converter. If I drag that into my graph, I can output the particle position into the vector input and then extract the y-axis. Now I want to test whether the y-axis is less than 0.73, so I'll use a less than node. So actually, if we use a comparison under math comparison under our tools menu, we can do a less than. And I'm going to test whether the y-axis is less than a second value. And sometimes it's a little easier to actually see the value you're working with if you use a scalar node connected to the input of the second less than input scalar, rather than double clicking to look at the second value. So I'm actually just going to grab a scalar value. If I actually look up tool constant, I can get a constant scalar value, which right now is initialized at 0. I'll say, let's just say 0.7 for now. We'll see where that goes, and we'll plug in. And if the y position of the particles is less than 0.7, we need to do something. So I'm going to delete the particles if that statement is true. Now, to actually evaluate whether or not this is a true or a false statement, we need a comparison node. And so if I look under execution, under tool execution, I have a conditional if node. And I'll bring that if node into my graph. And the if node needs to meet a condition or a Boolean flag. And the result of the less than comparison node, if I output that into my condition, this is what I'm testing. So I'm testing if this condition is true or whether it's false. So let's look at this again. If my particle position, the y-axis, is less than a value of 0.7, then we want to do something if that's true. And that something that we want to do is to delete the particles. You notice we have a node that deletes particles at age limits. We already have one node that's deleting particles, but now we want to delete particles based on our condition. So if I go back to my tasks menu and I look under deleting particles, in this case I just want to use a simple delete particle, not deleting particle based on any kind of attribute here. We want the particles to be deleted based on our own attribute that we've set up. So I'll pull in a delete particle compound, and again it's of type execute. The true and false statements are polymorphic ports, so whatever I plug in there, that's what type the ports will become. So if the statement is true, we delete particles. If false, we do nothing. I need to take this whole branch now and plug it into a port on the ice tree. Now this tree can get a little bit large with this 5-node tree or 6-node tree. So what I'm going to do is turn this into a compound. So if I was to right click and create a compound, one of the things you notice here is that we actually don't have any ports exposed to actually plug it in. So what I'll do here is I'll plug the if node into an execute. So I'll go in here, and if I look under Tools, Execution, I'll execute and connect the if node into the execute port. And then I'll select my entire effect here, right click, and create a compound. So this is my test compound node. So if I edit this, this compound node tests my particle position and delete if true. So it's a very long compound name, but you get the idea. I can just stuff it into my ice category if I was going to offload it. You don't have to offload every compound that you create. Sometimes you just need to create a compound for cleanliness sake. In my case, I would want to be able to adjust the value that I'm evaluating, 0.7, so I'm going to expose that input, and we'll call this value y. I'll close that down. So we have our y value exposed, and now I can take this little mini compound and I'll plug it in to port 3 of my ice graph. Now if I hit play, these particles are being culled out before they hit a position that's a little too low. If I adjust that y position, you'll notice at a value of 0.8, I emit no particles. So it's a very fine value. Even if I use 0.73, many of those particles will disappear. 0.75. Again, we find that cutoff value there. 0.74. So I'll use 0.72. Okay, the effect's starting to come along now. Now let's move along. So to refresh what we've done here, we've gone in and we've created a test based on the particle position y, and we will delete if that condition is true. Again, if I just dive into the compound I've created, we have a very simple ice graph to describe that effect.